My name is Usman Shakil, and I'm the Worldwide Tech Lead for Media and Entertainment for AWS. And I'm here to talk about designing for studio-grade security. And here with me is Eli Mezzi, who's an executive partner with Independent Security Evaluators, the ISC. And as I mentioned, we're going to talk about designing for studio-grade security. So the idea here will be that I cover some of the controls, best practices, and kind of drilling down into specific security features within the AWS platform that will be required or are required for, sort of say, your major projects or projects with major studios that require pre-released assets or tier 1 assets, if you will. So just a quick show of hands. How many of you in the audience kind of deal with security day to day in there? Okay, quite a few. That's great. Awesome. So some of the topics that I'll cover, I've tried to kind of set up this presentation so that it starts from the very kind of basic and kind of does a deep dive on specific areas. So if there are areas that you like to kind of deep dive further or have questions, please feel free to kind of point out anytime. So yeah, obviously security is a very important topic. I don't need to kind of come here and kind of preach to the choir how important it is with respect to security, especially when we are talking about high valued assets or high valued content, your IP. And it becomes even more important when you have the liability associated with it, because you are a service provider to a company that happens to be an owner of the underlying IP which is going to be produced. Right? And then when we talk about the studio-specific workflows, they're very complex workflows, as we all know. There are multiple different entities that are sort of say involved in those workflows. And then if you are leveraging, say, a cloud-based environment, which is a multi-tenant environment, it is very important to kind of pay attention towards some of these controls that may or may not be the case in the case of on-prem. So first of all, 5 security myths about the cloud. And the reason I put those in there, and some of those are, by the way, we are the different studios or customers are getting over as time kind of passes by and people understand the advantage or the benefits of using the cloud. But deep down somewhere the myths still remain. First one being multi-tenancy is inherently risky, right? So from our perspective, we're going to talk about how do you overcome this multi-tenancy risk. What is the risk out there, first of all, because of multi-tenancy, or is it legit? And then secondly, what do we do to kind of overcome that? In the cloud, I lose visibility and control, AKA I cannot go hug my servers. Incident response is harder in the cloud. In the cloud, I must choose between central governance and control versus agility and mission ownership, or shadow IT. Cloud is only appropriate for less sensitive data. More sensitive data is safer on premises. So, those are obviously all the myths. We've seen many of these kind of already being dispelled by the fact that we have, different industries, different highly critical workloads, from the PCI compliance to HIPAA compliance to federal government and all that stuff that I can get into, actually already working or running in the cloud. But more importantly, in the media entertainment space, right, workloads that are very specific to large-scale productions. Since morning, you've probably seen throughout the conference here that there are so many examples out there. So what are some of the baseline security standards from the media and entertainment perspective? So there are some common security requirements. There's the MPAA set of guidelines or best practices, Motion Pictures Association of Americas. There is the CDSA, that's a consortium or body that comes up with Content and Data Security Alliance, or Content Delivery Security Alliance, rather. And then there are major studio requirements that are specific to specific studios. So for example, Disney Marvel would be the gold standard when it comes to sort of say these best practices, but not to say that other studios won't take those security requirements near and dear to their heart, because at the end of the day, it is the high valued assets for that underlying studio that we are talking about. Then there is the Cloud Security Alliance, or the CSA, which are based on the standard audit parties like the ISO or the SOC, etc. PCI is another one. And then how many of you heard of the Trusted Partner Network, or the TPN? So 1, 2, 3, 4, 5, yeah, a few of them. So that's a good number. But basically, just to kind of revise what TPN is, the CDSA and the MPA, and actually Eli will be able to talk about it in much more depth than I can, but the CDSA and the MPA are kind of joining forces to come up with a set of controls that are going to be applicable for major studios, right? So there is going to be a trusted partner network, or there already exists a trusted partner network of the different ISV vendors, the different platform providers, the auditors, assessors, etc., that would be a part of the TPN. So from AWS perspective, what we are doing in that is we are a member, first of all, of the MESA Alliance, and we are working very closely with them in the TPN or the CDSA Tech Committee to come up with these sort of say new TPN standards that are going to come into being. So we know that we've established, at least with the examples and some of the stuff out there, that cloud can actually be much more secure for your high-valued assets or your high-valued IP. But why, right? One of the key reasons that cloud is more secure is because A, it's a platform which is built not just for media and entertainment, but it's built for keeping all the different stringent requirements of all the different industry verticals out there, whether that is healthcare, life sciences, whether that is financial services or government-specific workloads, etc. And it's not just that, okay, well, all of these security standards have been thought out and all of that stuff. There is a constant pressure from all these different workloads on AWS, on platforms like AWS, to kind of innovate much more in terms of security, to provide better services, to innovate more and more with respect to security features. And as a result, being on a platform which is built with that in mind and is constantly kind of stretching the bounds kind of gives you that automatic benefit, which, say, if you are building a data center by yourself, let's say a rendering facility yourself, you're going to be specifically looking at that problem from one perspective. Secondly, using the cloud and the feature set on the platform, right, that's very important, gives you this capability of choosing the default best practices, right? So just to kind of give you an idea, first of all, if you are in a data center space, you have an infrastructure running, say you have your render farm running, it's running forever until basically its life expires, and then you go and buy more infrastructure and then you add to it. Yes, you do patch management and all of that good stuff, but really running on the cloud is on demand. So you can recycle the infrastructure. It is all based on specific projects, etc. But actually pushing the bounds further, more importantly now, we can start talking about more modernized type of work architectures like serverless and microservices, etc., where these are all task-based, notification-based, very ad hoc or specific on-demand requests that are being implemented, whether that is in the form of Lambda functions or, as I mentioned, containers that are on demand. We actually have customers that are doing stuff using Lambda, using step functions, using microservices like container-based deployments on top of the cloud for both content production as well as content or media supply chain type of workloads like transcoding, quality checks, etc. So cloud-based, cloud security best practices, first of all, what are those? So the best practices are based on the industry standards that are not just, say, media and entertainment specific, but overall general industry specific, like the ISO, OWASP, CSA, PCI, NIST 800, 53, et cetera, and these consist of application security as well as the cloud security guidelines. And by the way, this is a reference directly from the CSA website or the MPA, right? So these are the standards that we are talking about. It's not really an audit, so there is really no requirement for an audit. Rather, it's a self-assessment or inspection. So we can go out there and say, the MPA requires all these different best practices, and this is how we align to these best practices based on the our audit report from, say, our ISO audit or our PCI audit, right? So this is how we align to these best practices. So that's the self-assessment. But where it becomes important is the underlying application that is running on top of it. So one thing is the infrastructure itself, which AWS can very easily showcase, and I'll talk about how, is that AWS aligns to these best practices that MPAA or CDSA, et cetera, require. But then the onus is on the underlying application, which is built by you, AKA your render farm, your pipeline management, your content, CMS systems or asset management systems, et cetera, on how these underlying applications align to the best practices that are being asked. But how do you accomplish that? Through the feature set, through the control set that AWS exposes on top of these infrastructure services that we give you. So key requirements for secure render, and this is, when we talk about this, this is really in context to whether it's a one single party doing the render or it's multiple different parties in this production pipeline, which could be a VFX house, which could be a third party which is managing the content delivery, et cetera, like a post house, and it could be the content owner that actually eventually owns the underlying assets. So the key requirements are, first of all, access control. Who has access to the content, that's the finished content, to the raw assets, and the underlying infrastructure itself, and the underlying application stack itself. So that's one topic that we'll cover. Network connectivity and isolation. How is your application, your render farm, et cetera, connected to other locations or other sort of, say, environments, whether that is an on-premises post-house facility, or it's like receiving the daily sort of, say, plates, if you will, and how are you delivering the final output. Data content movement, right, that's another one, whether that is over the network or physical. Storage security, so when the content is in the cloud, whether that is content or raw assets, whatever it is, what is the security around it? Cloud-based render farm or processing fleet security, the encryption of the assets, and then monitoring, logging, and automation of this entire workflow, and then finally, license server implementation, right? So these are all the topics that we will cover in depth. So first of all, a quick recap. This is an example architecture, very, very high level, of how rendering in the cloud could be accomplished or run. So on the right-hand side of the screen, you'll see the on-premises infrastructure where you could have your assets or raw assets, et cetera. On the left-hand side, you have your AWS environment, where in the bottom layer you have, say, or actually your assets could be either sitting in S3 on the left-hand side, or you are basically directly accessing those assets from the on-prem storage. Then you have some kind of a storage cache or a shared file system that you could implement or use a native service like EFS, Elastic File System, that Amazon offers. And then you're running a scalable render farm on top of it, typically an EC2 spot render farm. Now, you could take these assets back and forth. So let's say if you're writing those assets could be written directly on premises, or you can write it in the cloud and then transfer those over. And then you have an on-premises render farm that could be an extension of your render farm in the cloud, because your pipeline or license manager is either running on premises or you can run it in the cloud, depending on your implementation. So this diagram kind of shows you multiple different variations that you can see in a hybrid or a burst render environment. Okay? Different businesses are going to have different requirements. Different content owners are going to impose different requirements on the service provider, depending on the type of the underlying assets that are being produced. And so when we talk about security here, we're going to talk about it from the context of the very high level, like the top level requirement, like a tier 1 asset, if you will. So how can AWS make it easier for you, right? Because there could be so many different controls that I can decorate this environment for you, right? How do you manage that, hey, the content that is sitting in there in any of the storage layers is encrypted properly? If it's encrypted properly, what does that mean? Yeah, encryption at rest. How do I get access to it? How do I do key management? How is this content being transferred back and forth? Do I have my instances or virtual instances, virtual machines that are running inside the cloud, are they hardened properly? Right? What about my instances outside the cloud, on premises? How do these interact together? Right? So you can implement all of this with sort of say your traditional security level controls, like say firewall settings. You could say, setting up some kind of a VPN tunnel, etc. You could have a on-premises key management kind of a system like an HSM system that you can also use in the cloud, etc. Right? So there are ways to kind of manage all of this through traditional means. But what I would like to focus today also is some of these services that AWS provides you as a fully managed offering that are basically beneficial to you. Don't really cost you much, but make your job much easier when you're talking, say, you have to achieve a specific security implementation. So first of all, let's start talking about governance and access control, right? So there is the whole service around identity and access management, which offers you the capability to create users, create groups, and then offer permissions specific to different roles or groups, etc. Within IAM, you have this thing called the IAM roles. So IAM role is basically a virtual concept where it's not particularly tied to an entity. Rather, a role is assumed by a user. A user could be a person or a group or an application server trying to do a thing. And AWS gives you the capability to actually assume roles and actually do cross-account access. So let's assume the case where you have a dev account and then you have a production account. You could have an IAM user that you can have very restrict or specific privileges for. So it's basically least privilege principle, within security. So for those of you who know the different principles within security, would understand like the least privilege principle there. But basically providing the least privilege to an user within the dev account who then on as needed basis can have access to a specific task. So let's say a user needing to access a resource like an EC2 instance. So for most part, they don't have any access to it. They have to go through a temporary credential in order to do that. And this could be across multiple accounts. As I said before, a dev account, a prod account. You could also think of it as multiple parties. Let's say the content owner who owns the underlying resources and you being a service provider trying to get access to that other account. Right? Then there is AWS Organizations. That's a fully managed service. It gives you the capability, or it's policy-based management of multiple AWS accounts. One of the requirements that you're going to hear from the studios is that every single project or every single studio customer should have a separate AWS account. If you are a service provider, you have 50 different projects going on simultaneously, good luck managing it. So AWS Organizations actually does that for you, where you can manage all these different accounts based on policy. That for this project, I have this account. For that other project, I have that other account for user, etc. Cloud Directory is a multi-tenant directory-based store. So from a single sign-on perspective, from an identity management perspective, it's, again, a fully managed service at your disposal. So all these things really help you deploy a access control and governance within your AWS account for your different users. Let's talk about very quickly the cross-account access and KMS across different entities, right? So KMS is the key management service, and I'll cover it in more detail, but basically it is a fully managed service by AWS that gives you the capability to A, create your primary key, and then vend data keys to the users within identity and access management who have access to that. So just imagine a content owner having their content sitting in an object store like S3, which is fully encrypted using KMS, and then somebody outsider, like a third party, trying to access that content. So you give them one-time credential or one-time access to go and read that piece of content. Okay, fine, they read that content, but it's all encrypted. So they need to go and request a data key to decrypt that content to actually make sense out of it, and you can accomplish it through identity and access management through cross-account assume role. So key requirements for secure under let's talk about network security, network connectivity and isolation. So first of all, you can connect to your resources within AWS through either AWS Direct Connect and Direct Connect Gateway. So Direct Connect is a way for you to be able to connect from your physical location over to AWS over a dedicated network pipe. That's a service that AWS offers. So it offers you a dedicated throughput because it's a dedicated line. And then secondly, it's highly cost effective, as you will see from a pricing perspective compared to, say, your internet. And then the Direct Connect Gateway actually gives you the capability to connect to all the different AWS regions from one single direct connect. So let's say if you have connectivity from your location here in Vancouver to the AWS region down in Oregon, and you have another team sitting in London and they're using AWS London region, you can connect from that same direct connect here in Vancouver to London. So that feature was released recently and actually used in one of our customers' productions, Sherlock Gnomes, that you kind of heard earlier. Virtual private cloud is the capability for you to be able to create a private address space, for your own infrastructure within AWS. So you can bring your own address space and it's an isolated environment for you. You can decide to completely block any kind of internet egress for your VPC. You can decide through identity and access management roles, like what are the specific things that somebody can do within a VPC, and I'll talk about it in much more detail. You can decide what VPCs subnets are public versus what are private. And then there is also a feature around VPC peering that allows you to peer with a VPC which is outside of your account. So again, just imagine, let's say you are providing a service to a content studio or a content owner that has a VPC, and you have to get some information from their application layer through that VPC. One way is that, okay, it's an HTTP-based service, you go over the internet, you go talk to them, but then the other way could be that you work over a private address space. The way you do that is through this feature of VPC peering, so that you never actually traverse the internet, the public internet. Security groups and network ACLs, or access control lists, are stateful and stateless, rule tables that allow you per instance basis. So that's very important. These security groups are specific to single EC2 instances. So that, let's say, if in the very worst case scenario, it shouldn't happen, but let's say you open one instance to the entire public, well, there are other things in place, but that impacts only one single EC2 instance. It doesn't impact your entire render farm of 100 or 1,000 or 100,000 nodes. You can also set up a cloud-based VPN, which could be over the internet, and we offer you a default kind of service on that. Data content movement. So there are, when we talk about data content movement, there are, requirements around sort of say network-based content movement, which could be every single service. Let's say if you're putting stuff into S3, use the S3's SSH endpoint, right? Glacier, same way. You can go over the direct connect, which is a private dedicated line, as I mentioned. For VPC, you can also use S3 VPC endpoint that I'll talk about. And then if it's a physical movement where you're trying to move content around physically, right, you can absolutely leverage Snowball, which is basically a physical device that you can request through the console. It's over 80 terabytes plus 80 terabytes per device that you can request, comes to you, and then you can ingest the content in it and then deliver. It can also be used for moving content out of the cloud. So let's say if you have output that is stored in there and these assets need to be moved around, etc., you could use it. We're seeing a lot of kind of traction for this in the production type of scenarios where people are actually using it for on-set production. So let's talk a little bit about cloud-based render farm or instance security. So I'm sure you guys, all of you have some kind of a process of hardening your machines, the underlying images that are running on these render nodes, right? The patch management, etc., all of that good stuff. But so obviously you could either carry on the same process on AWS, or you can use hardened armies, the whole methodology on top of AWS, using, for example, things like from the operating system itself, like Amazon Linux, where we are managing the underlying patches and updates, etc., to the OS. CloudFormation for automating your entire environment. And then pay a lot of attention with respect to VPC architecture and design. There is a lot of literature out there with respect to what is the best practice. Should you have one VPC, or you should have 3 different VPCs, etc. But at the end of the day, you want to focus on decoupling the VPC. Within VPC, you want to decouple the location or that network location where your high-valued assets are going to be. So for example, your render nodes live inside their own VPC. You could have another VPC for things like monitoring or other admin level tasks, which are separate from that, but could communicate via VPC peering. Just a kind of very high level example. Same goes for license server implementation. Many times you'll see people wanting to, or the license servers actually wanting to call home over the public internet to check out a license, right? But in your render farm, you do not want to put your render farm up on the public internet or egress into the internet. How do you accomplish that? A couple of different ways. One is you can route the license server traffic over to the direct connect or VPN back to your on-premises, and from there go talk to the network, which is like an entire loop. Or you can basically create a separate VPC for your license server. So it's purpose-built VPC just for it to actually be able to go call home. And then you can peer these two together so that the render node that needs to check out a license can then go talk to the license form. So there are, few different ways to kind of say accomplish that. The point being, VPC peering, VPC itself give you the capability to actually implement that. Couple of different services that I'm going to talk about that are highly important here and can be very useful. So again, you can leverage all of that or do all of that yourself. You can manage your machine images yourself. You can control your patch management and OS versioning and all of that stuff yourself. Or you can also use AWS Config. So AWS Config is a fully managed service that allows you to audit, assess audit, and evaluate the configuration of AWS resources. So with one single call, you can actually find out what are all the different OS versions, patch versions, upgrades, etc., running in your entire AWS account, right? So that's very powerful. Like how many times you can actually do it on your data center. It can continuously monitor the record your AWS resource configuration. So resource configuration is a kind of like a feature within config that allows you to automate the evaluation of recorded configuration. So you can have, let's say, as I talked about, a golden image, right? Or a configuration specific to your render nodes, etc. And it can monitor if there has been any change, whether programmatically or by a human being or admin or whoever, and what happened to it, right, with respect to the desired configuration. And basically, the end result is, A, you get ultimate visibility for each and every single thing that's running within your realm, within your account, right? But at the same time, it makes that audit process super easy. Because in the end, guess what's going to happen? I'm going to tell you, yeah, we've gone through all these best practices that align to MPAA, but somebody has to come in and say, yes, you check the box and it's being audited. So things like this, right? It actually generates or spits out a report for you that you can take to the auditor and say, look, here's my entire infrastructure that is running this thing. So AWS Systems Manager is another very important thing. It helps you with resource monitoring, not just within your AWS infrastructure, but also your on-premises resources. So in this example, as you can see, and it offers you a single unified operational UI, right? So in this particular thing, as you can see, down there, you have, say, a couple of different VPCs, could be for different reasons. One is for Linux instances. I would say probably running your render farm. Another one, EC2 Windows instances, I don't know, doing something else like checking email or something, or some other a process that they are doing. And then there is the on-premises resources, right? So the Systems Manager is actually going to, again, scan all your resources across within AWS as well as the on-premises infrastructure, and then against the patch configuration and the custom policies that you've set up. And then it's a centralized store to manage your configuration data. For example, your database strings and passwords, right? So then many times we hear, well, somebody checked in their credentials or their password in their GitHub library or in their code, right? And then, oh crap, what happened, right? In this particular case, if you're using this, basically all the secrets are being managed by the Systems Manager itself. So it basically, again, a good practice to have. On the storage side, I could spend a whole day talking about what are the different sort of, say, controls within storage security, or what are the best practices, right? So I would say that the default storage settings, let's say within S3, etc., are out there for your benefit. So for example, when you go create a bucket or you put something in a particular bucket, only you as the owner have the ownership of that bucket and also the access to that bucket until you as the owner of that bucket or that object explicitly go and open it up to the entire public, if you wanted to, I hope not, or you give access to somebody, right? So oftentimes we hear, well, somebody's S3 bucket opened up and it leaked a bunch of stuff. Well, that's how things happen, right? Because it is an accident, obviously, but why, like even in the case of an accident, it is actually the very first principle that we talked about, the least access principle, right, is not being followed in this case. So nobody should have that access. And by default, every single object that you put inside of S3 or anywhere else should be encrypted by default, right? And then you can actually leverage KMS on top of it, the key management, to bring your own keys if you wanted to, and then use access control and proper sort of, say, whether signed URLs or access control to the key management to be able to vend these encryption keys. EBS, which is our block store, let's say the actual sort of, say, disk or the volume that you're adding to your render instances, you can encrypt the EBS volumes or EBS boot volumes or data volumes as well. There is an option for that. I covered that already, but again, key management is a topic that you want to put a lot of attention to. Depending on the different use cases, there is going to be a specific architecture, right? So for example, just kind of give you an example here, we have some customers where they would like to put a single primary key. And for every single title or every single file associated with that title, there is going to be a data key, which is like, say, a separate data key for that. And there is a whole key repository or key storage that you can have, or use KMS to kind of vend those keys. There are some other customers that want to go to another extreme, where it's instead of one single primary key, it is one primary key per title. It really depends on what is the scale we are talking about. What is the value of those assets? Let's say if you have a very high valued, let's say, full-length feature film versus an episodic content, right? So that's where you're going to see different key management system architectures or key architectures for different use cases. VPC Private Endpoint and Private Links, I already covered it, but this example kind of takes you in a little bit more further detail. As you can see on the left-hand side, one of the VPCs is actually going to a high value, or actually one of the subnets rather, is going to access high valued assets. Just imagine, like, you have tier 1 assets in an S3 bucket. And then there is a bunch of stuff which is, say, metadata or other stuff associated with it. It could be metadata, it could also be things like, sort of say your deployment, your code, etc., which is somewhere else. So you can really segregate, even within one single VPC, you can segregate your subnets so that through the route table and through the endpoint, the VPC endpoint, you can actually configure which VPC can access what S3 bucket or what S3 bucket location. So then you can really lock down the access to your tier 1 assets with respect to a specific processing setup that you have. Same goes to, let's say you have resources that are in S3 that are, say, your tier 1 assets. Now you can lock it down such that the only way to access those assets is through VPN or through DX. Even though S3 provides you a public endpoint, this capability through VPC, S3 VPC endpoint allows you to lock down your S3 bucket completely, so that if somebody somehow went out there and opened up access to S3, like say, as I said before, provided a public link to S3, even with that accidental thing won't happen, because it's also locked down at this layer where all the requests have to come in through this VPC and traverse via the VPN or direct connect. Monitoring, logging, auditing, and automation. That is very, very important. So there are so many services out there that offer you at each level, like some level of automation, auditing, and monitoring. So CloudTrail gives you the capability to monitor each and every single AWS API or CLI request that was ever called by any user. Somebody went in, changed, tried to access a bucket object, it'll be logged. Somebody went in, tried to open a port on a particular instance, it'll be logged, just as an example. VPC flow logs. This is a service that gives you the capability to actually monitor every single packet that is flowing inside and outside of your VPC. Just takes you to enable it, and that's it. CloudWatch. Obviously, you can monitor all your resources, but CloudWatch logs goes a step further. Now, just imagine you had VPC flow logs, which is your network packets or network traffic in and out. That you can take, funnel it into CloudWatch logs, and then set some specific regular expression flags on it to alert you when some bad behavior is happening. Somebody is trying to access an instance inside your VPC. You want to know, this is how you can know it. AWS Inspector is a capability that actually monitors your entire targeted infrastructure and pinpoints anything specific that may be a problem with an audit. So things like PCI audit or anything like that. You can set up an environment which is specifically being monitored with respect to an audit. Amazon GuardDuty and Macy are again very important services that I'll cover in more detail. But basically what GuardDuty does, it is a managed threat detection service that continuously monitors for malicious or unauthorized behavior. And it has machine learning built in. So basically it looks at the trends of how your resources are being accessed, and based on that, it can actually alert you. And so one other thing is this last point here, it also detects the compromised instances, potentially compromised instances, and anything that of harmful nature by any kind of attackers. So there's a lot of sort of say smarts built into it, for the lack of a better term. Macy is specific to Amazon S3. So what it does is it again looks at the underlying assets that you've stored in S3, and based on the underlying patterns, it recognizes the sensitive data, such as if you have some kind of a PII data in there, right? Or any kind of like say intellectual property, like high valued assets, if you will, right? And then it provides you dashboards and alerts to give you the visibility how each and every single aspect within your S3 bucket have been accessed or moved, right? So any kind of a problematic behavior could be flagged very quickly. But I guess more importantly, what we are seeing is, so a lot of these things, I mean, you could implement with your traditional architecture, right? Like, what is a traditional architecture? You've got a bunch of storage, then you've got a bunch of servers on top of it, kind of very similar to what an on-prem system does. But what we are seeing more and more, and this is where actually the real value proposition of the cloud shines, which is modernized architectures. So as I mentioned before, when you start looking at things from a serverless, purely a serverless perspective, and serverless could be Lambda, it could be step functions to kind of cover your workflow, or microservices in the form of, say, container deployments, et cetera. What you're going to see is basically at the end of the day, the infrastructure is on demand, triggered by a specific request. So every single render job will have a brand new infrastructure spun up for its purpose on demand. So that right there takes care of a lot of vulnerability issues that arise from stale or long-running infrastructure that could have issues with respect to whether that patch is not up to date, or the machine image is not up to date, et cetera, or if there are any vulnerabilities that are happening because the infrastructure has been online for a while. A lot of times, so this is one of the security myths out there that I talked about earlier, right? So yeah, you can use the cloud for all kinds of burst rendering up and down and everything, but you cannot really write the output in the cloud of your renders. How many times you've heard that? Yeah, a few times maybe, but I hear that a lot, right? So we worked with our friends at ISC, and we came up with this architectural pattern that actually allows you to write the output of a render in the cloud. So why would you want to write the output of a render in the cloud? Because first of all, it's going to be much more cost effective. Every time you're writing stuff or egressing stuff out of the cloud, there's cost associated with it. So instead of sending out every single rough frame or rough output, you want to consolidate in the cloud and then send out. Secondly, from a architecture perspective, it is much easier if you are writing next to where you're processing, because otherwise you're going to go over the network and there's going to be added issues with respect to latency. Right? So that's where there is a lot of benefit. And actually what this architecture is doing, without kind of going into the detail because we're running out of time, but it is actually using the same kind of principles as we talked before earlier with respect to key management system. So it is leveraging key management system with primary key being owned by the content owner, and the underlying render machines and the render machines that have the EBS volumes encrypted by that key that is owned by the content owner. And then for every single job that is being run, it is a assume role kind of a thing to get the key in order to encrypt or decrypt that content. Hybrid render workflow. So this is more like a decorated form of the very first slide that I showed that was a hybrid render workflow, right? So in this case, again, you've got your on-prem with the direct connect. You are pushing content into the cloud, and then whether that sits in S3 or any kind of a shared file system like EFS or anything else with a partner ecosystem that we have, you can actually use assume role on your render nodes to actually be able to read or write into assets within AWS. That could be S3 or EFS, or use KMS for encryption, and then CloudTrail and IAM. This is another example for review and approve workflows, so like digital dailies, if you will. So the other thing is like security by design. So this is actually a program that we have, because at the end of the day, as I talked about, there is so many different things. There is IAM, groups and roles, public or private subnets. There is who will manage the keys, which databases, and et cetera, et cetera. And it's all dependent on the underlying workflow that you're trying to implement, right? So we have this program called Security by Design, and what this does is it's a security assurance approach that formalizes AWS account design, your security controls with respect to your network infrastructure, your VPC infrastructure, and all of that stuff. You can go to that link down there and actually read about this more detail. But basically what it does is first decide what to do, right? Like what is your underlying workload that you're trying to move. That could be a render workload, that could be an asset management piece, and they will also assess what type of content that you have, whether that is tier 1 content or it's some kind of a already released type of a content, and then what kind of security requirements are going to be needed. Then you analyze and document, even outside of AWS, what are the rationalized security requirements with respect to, does it require PCI level security? Does it require something less than that, et cetera? And then you document a security architecture, automate, deploy, and monitor, and then finally you get certified. So there is, across this process, what you're going to see is there's help that AWS people can provide, whether that is solution architecture or professional services, et cetera, throughout these steps. And then we work with our partners like ISC to kind of deliver you, at the end of the day, a checklist that you'll take it to the auditor that actually audits you for that specific studio requirement. So we worked with the MPA, or as I said before, looking at the MPA best practices and aligning it to our audit reports. It's on our website. You can go check it out, how AWS fares. Basically, what you'll see is there's a complete one-to-one mapping across all these different AWS services, across these audit reports. Then we worked with our friends at ISC to create assessment for, or hardening guides for the burst render workflow, but also asset management and archive, right? So this is where it's really important that you talk about that it's not just for burst processing, but actually writing tier 1 assets or storing tier 1 assets in the cloud. And then how do you get done? I kind of covered it a little bit earlier already, but basically you're building your environment based on the template that's provided to you with ISC, and then you, or if you need help, we are here to help from professional services perspective. And then you create your environment report that could get audited very quickly by a third party. So with that, I'll invite Eli up on the stage to talk about a case study, how we actually did that for the Sherlock Gnomes project with Paramount.
Thanks, Usman. Well, that was excellent. Really appreciate the introduction. As Usman mentioned, with every one of these productions, there's quite a bit that needs to go into it, from the inception and idea to identifying your problem, through implementing it and getting stakeholder buy-in, and actually testing your render. In the case of Micros, we started at the very beginning, where you identify the use case. In this case, I tried to make this as simple as possible. Hungry customer orders food. That's the use case. If you're hungry, you will get food. In the case of Micros, it was, we have infrastructure. We have an on-premise solution. We know that we're going to need to render hundreds of millions of hours for this film upcoming. How are we going to do it based on the infrastructure that we have, technology partners that we have, and do it in a secure manner with buy-in across the board? In order to do that, what they did was identify their current limitations. So they know if they have 20,000 cores on premise and they need to render 100 million plus hours of VFX shots, that they're going to need to be running their render farm 24/7 for about 180 days, which is not acceptable for most productions. We all know that productions need to get the job done by a specific date because deadlines cannot slip, and they can only start working once all the materials are ready under the hood. So by coming up with the use case and identifying the current limitation, they were then able to go ahead and get stakeholder buy-in. This is probably the most complex part of the process. And stakeholder buy-in is internally at your company as well as externally with content owners. So in the case of Micros, Micros is a wholly owned subsidiary of Technicolor. They needed to take their use case, present it to stakeholders at Technicolor, explain why the current situation, why their current infrastructure was not workable for the Sherlock Gnomes project. And Technicolor, in turn, needs to actually turn around and speak with the content owners to get approval to move into a different architecture, knowing that they would not be able to meet a deadline and actually deliver a finished product by the date set. This sounds really simple, but this is something that takes a bit of time. It does require change management. It does require clear lines of communication, both within your organization and externally to stakeholders who are going to be interested. Once they were able to do that, they needed to map out a workflow. How are we going to make this work? How are we going to take the infrastructure that we have, bridge it securely to a cloud infrastructure, know what resources we need to pull in to do this, get all of our technology together, prototype it, implement it, deliver it, and make sure that it's all done on time and under budget? Well, workflows are everything. If you understand that workflow, if you understand the security model that exists on premises, and you know that you can extend that out to a cloud provider and either recreate it faithfully or enhance upon it, as Usman was talking about earlier, it's an easier sale. So Once you're able to map out the workflow and you know exactly how the technology is going to work and you have an idea of what that solution will look like, you start prototyping. Prototyping is incredibly important. As you move to the cloud, there will be kinks that need to be ironed out. There will be unforeseen bends that you take in your workflow that you need to iron out, and also the unknowns. So in the case of Micros, we ran into an issue with latency, where they were trying to bridge their on-premise infrastructure and create a hybrid model within AWS. And as Usman had mentioned, their facility was not geographically close, or as close as needed to a data center in order to actually satisfy this use case and have a workable solution. So as they were prototyping, as we were working through this, that is something that was identified fairly quickly, and we were able to take a step back, look at the workflow that was mapped out, look at the stakeholder buy-in, look at the problem that we had, and come up with a solution. And that solution was actually using persistent storage in the cloud with encrypted EBS volumes. Once you do that, because there has been a change and because the prototype is now ready to go, you need to go back to your stakeholders and go through that approval process one more time. This is internally at your company, or in this case with Micros, through the Micros organization, then out to Technicolor, and then Technicolor out to the content owner, and in this case, content owner was Paramount. So it was through that documentation process and through the prototyping that we were able to fast track stakeholder approval and greenlight a project and a workflow that had really never been done before. And this is something that we're able to rapidly iterate on and get completed in a matter of days, which is astonishing considering the amount of complexity that usually goes into planning infrastructure and making sure that you have all of your resources ready for a project of this scale. So once you get that stakeholder buy-in, you then go and implement the design. And because you've gone through the prototype, because you've documented your workflows, because you've documented all of the controls that are going to be a part of this, implementing the design should be easy, especially when you work with something like AWS. As Usman mentioned earlier, once you come up with your control set, once you know how each of your services are going to be configured, once you know what security controls you're going to be placing on each of those services, it scales beautifully. It's hard to change it. You actually have to make a concerted effort to break or change the security model, at which point you will be going through change management, and there will be alerts because of the built-in mechanisms that the AWS platform affords you. So if that sounds familiar, it's because the Secure by Design program that Usman was talking about is exactly what we did in the case of Micros. This is something that has worked in real-world scenarios and can work going forward. The most important part is just making sure that you have that information up front, leveraging the resources that are made available to you, both internally at your organization, as well as with your cloud provider, and then going through the appropriate communication channels. There are 1,000 different ways that you can solve any one of these render workflows. Every one of them can be correct. Every one of them can be incorrect. It all depends on the design and making sure that you have that buy-in and that vetting. In the case of Micros, AWS, ISC, and the content owners were heavily involved through all decision-making processes, and it created a very fast turnaround that allowed us to just blaze a new trail. So I know we're running pretty short on time. With that, I'll invite Usman back up here, and we can handle any questions that you may have. Yes?
With the key storage management system, hi. With key storage management, is it the case with the studio environments that they're requesting the key and it's their key and that it's their KMS and that we're just getting a...
Not necessarily. No, they're requesting that KMS be implemented in a way where you can manage on a per project basis. Okay. So if you know that there is a tentpole that is upcoming, they will want to make sure that that key is not, that key is unique to a given project and that it's not being used on multiple other projects.
Okay. And then, is there another question? Or I have another? Along those lines, one of the things that the cloud provides the studio the ability to do is to have ultimate control, say like a company goes into receivership or something like that. Would just having that individual key allow them to be able to still maintain their assets? If it's my AWS accounts, right? I'm a vendor, and then I go Chapter 11, right? how does the studio get their content out of the cloud?
So can I answer this?
Yeah,
So one way to do that would be like, let's say the studio has required you to encrypt that content using say a specific key that is in your control for those assets, right? Now, ongoing basis, you are going to be delivering those assets or output assets to the studio, right? Now, that workflow is going to be separate from this particular one, where what you're going to do is you're going to deliver these assets to the studio. These assets you deliver to them are encrypted. That studio then, or the owner, is going to request a cross-account access to that key to decrypt that asset, get that asset, encrypt it with their own key, and store it in their S3 bucket. So, I mean, that kind of an arrangement could be done very quickly. The other thing that I mentioned earlier was that whole VPC peering thing, right? So through that VPC peering, you can do that handshake where, well, it's not only just through this cross-account assume role for the key management, but also all the assets are flowing through this VPC peer that you set up.
Any other questions? Yes.
Thanks. The question is for Eli.
Yes.
You mentioned that there was an issue when you prototyped the workflow for Micros. Was it a compromise to put in place just a caching layer rather than full cloud storage for share of node?
So we could have gone down that route, but putting a caching layer in place requires significant expenditure on your part, where you're purchasing appliances, purchasing licenses, and creating a workflow from scratch that does not yet exist. When you need to iterate rapidly, leveraging battle-tested services that are available to you by a provider like AWS generally tends to allow you to do that far quicker than if you go out and purchase caching cluster and then caching software and then going through the process of benchmarking it, testing it, and running through all of that work.
And specifically in their case, just to kind of add some color to it, so the problem scenario was they were using, as I don't know if you attended the Micros presentation earlier.
Yes, I did, yeah.
You did. So basically they had their office in Paris where they have your graphic artist, and they're connected to the nearest region, AWS region that you have at that time, which was Frankfurt, right? So the requirement that Paramount had on them was thou should not write any render output in the cloud. If you don't do it, then basically you have to go to basically you're writing to an NFS mount point on premises. So NFS file system, for those of you who know the details around it, you're going to run into timeouts if you go beyond a specific latency, right? So when we started hitting the scale for Micros, right, or the underlying kind of say the infrastructure that was needed, very quickly we realized that we will need to go beyond Frankfurt across multiple regions to kind of meet the demands of the project at the cost-effective rate, right? So that's where two things were important. One was that we have very, very quick direct connect access from, so initially in the project they had direct connect from Paris into Frankfurt, but we had to make sure that we also have direct connectivity to this Dublin region, which is one of the largest AWS regions, right? So that's where we leverage the underlying direct connect gateway, right? So that was like a brand new service at that time. So obviously you have to go through, hey, is this securely vetted? You know, what are the different controls around it, et cetera? So that was one thing. But then more importantly, we started thinking that, okay, well, you can leverage it this way, but wouldn't it be useful if you are able to actually write the output in the cloud and then downstream take it after the fact? Because if your active process is writing directly to a mount point that has a high latency, you're going to run into issues, right? That's the speed of light. So that's where we worked with Eli, with Paramount, with Technicolor, and we kind of came up with this architecture around KMS of, hey, you can actually use a caching solution, but the underlying storage for that caching needs to be encrypted by using KMS keys, which could be, you know, done in a proper way. So that was the key aspect within that project that we have to come up with, you know, like a design for being able to actually write it in the cache in the cloud. Does that kind of give you the answer?
Yeah, that does answer, but I thought from what you were proposing earlier that did store in the cloud, but sounds like they didn't accept. I guess the studio did not accept that, and you just put in place a temporary caching solution. And
No, so the from that perspective, even in the case of the caching solution, right? You got to understand that you are writing stuff. You're writing an output in a storage that lives in the cloud, whether that is a cache or lives there forever. The storage is in the cloud. So the key was, how do you encrypt that storage in the cloud, right? So that's exactly what we ended up proposing to them.
cool, thank you.
All right, thank you very much.